Okay, now we will start the chapter 2, part 2. Last time we talked about the variable and the name, the ID, the token for the variable. Now today we will actually continue that, and then we'll get started last time where we actually discuss the literal. But before we move on, let's review the memory model. The memory model. Each program in C language or in even any program in our modern computer would have some data like this in memory. So your program, the code, your program code will be stored in the so-called text area. Actually, it's called code segment. Code segment. And then you put over here, it's actually called code segment. And then there is a code segment register in your processor, in your i7 processor. Okay. Then there is a data segment. Data segment is over here. It's called DS. There's another DS register. And then at the end, there's a stack segment. It's called SS. Okay, and I explain like the global variable will go to here. And then local variable will go to here. This is global. This is local variable. And then your dynamic variable will go to here. Okay. Now, before we move on, I'll discuss the pointer and the variable in C language. And also, it's also good for C++. So here is the whiteboard. Let me get started. So if we declare some variable called integer a equals 3, right? It actually has a 3 in certain memory location, say 1F, 3B. That's some sort of address, right? And then there's a variable name called a. So we have 3 things. One is the name, one is the value, and one is the address. 3 are created for this variable a with this statement. Okay, with this statement. Now, let's look at how the pointer and things are working. If this statement is Java language, actually you don't see the address at all. So pretty much you know a name associated with a value. But in C language, it's different. C language has a concept of address. And address, actually, if we look at a variable a, you can have an a assigned to b, and now we call it right-hand side value. And apparently, right-hand side value is 3, right? That's the your memory location a. You have a 3 over there assigned to b. So actually, this thing copied to b for the 3. We call it right-hand side value. Okay, this is called right-hand side value. And if we have a equals 5, after the a equals 3 got assigned, your variable a pointing to here. In fact, this one we call it left-hand side value. It also called as reference. So in fact, this 5 assigned to here. So this guy, you get the left-hand side value. It in fact is pointing to the body of this variable, and you put a 5 assigned to the left-hand side value. That is left-hand side value. But this is called reference. It's not even pointer. Okay, that's actually the pointer, the reference. Now the third one. The third one, if we have this integer a equals 3, and then we actually have integer star P equals address of A. What does this mean? The first one, the red one, we declare a variable with address 1F3B, something like that. And then we put a value 3 over there. That's the address of this memory, and the name is A, right? Then we copy the address of this guy to a variable called P, and that variable is put a 1F3B over there. And then this guy, we call it, the body of P is an integer. The body of P is an integer. This guy, we call it body, and sometimes called object, or sometimes called dereference. It's a reverse operation for reference, so it also called dereference. So the body of P is actually, it's an integer, and P got assigned with the address of A. So actually you put this, and then this P become a pointer to this A variable. But remember, this one actually is a declaration. So if we actually do not assign a value over here, and we just do this, and later next line, which we can put, the next line we can put P equals address of A. Okay, so this side actually we just declare a pointer, and right here we save the address for this guy to there. So this S sign actually is for the address, and star sign we call it body. Okay, so we assign that value to P, and then this P actually pointing to the 3. So we if we say this, if we actually do this, if we do printf P's body, this one will print 3. Any question?
这样为什么不要直接 P 等于 A？
A is a name, a variable. It's a reference. Left-hand side value. It's not a pointer or an address.
对，可是你为什么是要给它的 address 才可以，是不是？
Yes. For pointer, you need to assign the address for it.
这样为什么别的 code 就可以 integer P 等于 A 就可以了？
That's Java. Java's reference have no difference between pointer and reference. So Java reference actually work for pointer and also work for reference.
这样为什么不行直接 integer P 等于 address A？
Integer P, actually this P is a variable.
对啊。
And it is an integer. It's not an integer pointer.
为什么一定要 integer pointer 才可以？
Because it's your whole address.
这样为什么要 whole address？ 为什么不行直接就 A？
Because address, if you put integer P, it will actually if integer B, it will get the value of something and assign to there. And even if you assign the address to there, you have the 1F3B, right? And this guy actually store the value of this. Maybe when you print, it will be like 3, 5, something. You cannot use this one as a pointer to do.
So integer P 等于 address A， 它就会直接印它那个 address， 是不是
Yeah.
那如果我用 integer pointer P， 它就会印出来。
No, you still need to. You have the capability to do dereference. So you can do dereference.
什么是 dereference？
Dereference is find its body to get the value. So here, if you do integer P equals address A, right?
Yeah.
So address A will give you, so when this one actually P is stored with it actually 1F3B, right? So when you print, you can print this, but if you want try to print body B, no, there is no body B because it's not a pointer.
So body stores the value?
Body store the value, yes.
And then P 只是 store 它的 address.
P, this one, if you use integer declare as a pointer, this one will store the address.
Okay, and then star p 就会 store 它的 value.
Star p stores value. Let's try def c double plus. Okay. Let's try this one, the program, to see how it works. Okay. So let's bring up this def c double plus. Now I new a project. Okay, console, and I select C project. Okay, and then let me see. Let me store to chapter 2, and then let me call this project as pointer 1. Okay, so this is a pointer 1, and let me actually do this. Let me declare it as a global variable. Okay, so integer a equals 3, integer star p equals address of a. Okay, so now let's see the difference. Okay, so right here I have a print this guy, a print f. Okay, and then I say a equals here I have, if I say body of p equals, okay, so here if my pointer p assigned with the address of a, right, and I print out a and body of p. Okay, these two guys has no difference, right? These two guys has no difference.
就把那个 star 拿掉。
Yeah, so here I put backslash n. Okay, now if I print f, and I say here instead of having this, I say p, and I still print out d, and now I print p, right? I print p. So p is actually a pointer, but I print the value of the pointer as integer, right? And here I still need a backslash n. And then there it is, and I print, right? P is some sort of a value.
这样 p 等于 a 是会做什么？
So let's do another thing. So if you want to do this, you continue to do this, and I actually here I have address of a equals okay. Now I try to print the address of a. You see that? You see that? So
这样
p
p 等于 a 是做什么？ p 等于 a 是会做什么 ？Nothing。
A's value will be put to the so here if I have the p now, if I have the p, right, but p updated with a, what will happen? So you actually assign the right hand side value of a, and that is 3 to p, and p is a pointer, right? So let's see what will happen. Let's see what will happen. Let's copy this. Okay, right here. And now actually I just print p. Okay, print p. And then I also try to print body of p. See what will happen. Okay, it doesn't pass. You know, there's a warning. There's a warning assignment. So actually this time what happens? I think it will still go through. It's only a warning. It's not an error. But what happened is like now my p actually assigned by 3, right? But my body of p is using the 3 as a pointer. So you go to the address 3 to get the value. You use a 3 as the address, and then you use the address 3. It's no longer using the 42 something to get a value.
So P 等于 A 就是拿到它的 value。
Value, yes.
这样为什么它这样不会 work 呢？
See here, right? See here, right? And as you can see, like this one, it print out P equals 3, right? This one print out COP, right? But next one, what happened? It print nothing because it has a segmentation fault. You go to the wrong address and trying to access illegal addresses. So body of P is not allowed to be printed. So you are not trying to print something legal. You use the address 3 to access, but address 3 is not a legal variable or memory allocation.
对，可是这样 P 等于 A 就可以直接 assign 它的 right hand side value， 这样我们一定要用 pointer。
This one P equals A is get the right hand side value is get it in 3.
对啊，
But P is a pointer.
但如果 P 不是 pointer 呢，就是直接 integer P 等于 A。
Yeah, that's fine. That's just like normal. That's just like normal. You assign A to B, B to A or something.
这样为什么不要这样做呢？
Yeah, but pointer. Okay. Now the question is like, what is the purpose for pointer, right? Now the question is actually, what is the purpose for pointer? Now would like to say I have this void function update, right? So if I put something like this, I actually want to update my P, my value A. So if here I have an integer A, right? And I say B equals A, right? And this integer B, so I say integer B, right? And then that's okay. Let's do this, and that's B assigned with B, right? But I try to update the A variable, so that's not using X A, that's use X and Y. Okay. But here, if I say this one update A, right? I'm sorry, this one is actually, so I should have an integer Y value. So I actually do X, I update X with the value Y, right? So here, if I want to update A with 5, right? If I want to update A with 5, but this one actually after the update, A is no change. A has no change over here. So that's
因为它是在 update X， 不是在 update。
It's actually a local variable. It actually is a local variable. Let me try again. Okay, that one is not good. It actually is a local variable, so it's not changed, right? But here, if I say X is a pointer, and instead of using A, I assign the address, right? And I say body of X assigned with B, with Y, right? And this one actually it will work. A got updated to 5. Okay, now let's look at this case. Okay, let's look at this case. Let's look at this case. The first one, because C language is called by value, right? So basically over here, because C language is called by value, so basically over here, X I assign as a pointer. So X's value actually assigned by address of A. So when my A has an address 1F3B, my value is 3. So X actually stored with 1F3B, right? And then later I go into my update function. So later I go into my update function, right? I go into my update function. So right here, actually, body of X, you use this pointer pointing to here. So body of X is right here. right? And then body of X got assigned with the value 5. So actually right here, I update this with 5 over here. So when you, in the outside, you actually print A, you actually get print 5. So in C language, if you want to update a variable A, you need to, in the function, if you want to update a variable, you need to upgrade it by 1 label pointer. Update it by 1 label pointer. But if you don't do that, actually it will be called by value, so it won't happen. So if right here, just as before, we don't have this pointer, the variable will not be changed. The variable will not be changed. In this case, the variable will not be changed. In this case, it will not be changed. It will be just print out a 3. It still, this will print out a 3.
如果你直接 update return x 的话，它是
You can do that, yeah. You can do that. You can
它会
do
5对。
Yeah, but that actually you can do this and then you assign it to A equals, that's fine. If you have the
这样
integer.
就会是5对不对
Yeah.
？OK。
Yeah, but what's the purpose of having this? And here actually you need to return X or something. Okay, or return Y, some one of it. But I actually need you to do this HR assignment. But if you don't like that, you actually want to do this. So this one actually, if you look at this, one with star and one without star, the one without star is just putting in the value. The one without star is just putting in the value. And then the one with star can update the value. So this one is input. This one is actually in-out variable. Remember that in your C double plus, you can declare something like this. It become an in and out variable. But that is alias. But so C double plus, you can assign this by this. And then that got updated because it's using alias. So using alias or reference is easier than pointer. This is C double plus. This one is C. Using alias is actually a little bit easier. Okay, but pointer has other purpose. Pointer also being used for dynamic memory.
那什么意思？
Dynamic memory stored in heap. Okay, so now let's continue to look at this. Here, if I continue to do this, and so this part, let me delete this, right? And then here I get to go actually keep it as void. No, something wrong. Let me see. Here you need to put the H's in there. Okay. And you print, you have this, right? Now the next one, actually, I try to create a dynamic memory for something. So here I have a P, right? So my P actually also can do this memory allocate. So I actually memory allocate. And this is fine, but I usually would rather to convert it to integer. You will return the pointer, but I usually put a casting to make sure you will convert it to some sort of integer pointer. Okay, something like this, and then I can have like this one, body of P equals 7, and I can do A equals body of P, and then print F. Let me copy that down. Okay. Print that down. Okay, and run. Okay, A becomes 7. What happened right here is what? I have a pointer like this, right? And actually I allocate a memory size of integer size. So what happened is, as I mentioned, there are 3 types of memory in C language, right? So the first one, I have this A is actually global, so it actually stored in the global area. There's a A, right? But this one, when I do memory allocation, there's a heap. In the heap, I allocate some integer over there for P, for P's body. Okay, so the P's body right now I store a 7 over there, right? And later I assign the body 7 to A, so A becomes 7, right? And what is the difference? What is the difference between this dynamic memory? This one's dynamic memory. So eventually, what should I do? After I finish the program, what do I need to do? I need to free P. The whole program in order to avoid memory leak. Remember that one? Memory leak. Okay, so to avoid memory leak, I need to free that one. So allocate and refreeze. In C language, it's free. In C++, it's delete. Remember that? If you use new, you need to use delete. If you use this memory allocate, you use free. And there is another one called C allocate. We will meet that later. That also need to use free. Okay? And then what is this? What does this really mean? You have something called global area, right? You have something called local. You have something called heap. 3 different areas, right? So right here, we have A over here, P pointer is over here, right? And then the global one, we have not, I'm sorry, this one, no, I'm sorry, wrong. We have the A and the P pointer over here. We have a heap data, that is the body of P, that's the body of P. So this one is a P is over here. P is a pointer, a body of P is in the heap. Okay, and then why we want to put the body of P in here? Let's compare, okay? Let's compare. Let me actually clean up all these. Okay, why we need the body of P now? So as I mentioned, if I declare as global, it's static. Static means if I declare a variable A, static means it will, when your program start, the A will be alive forever, right? And then if your variable is local, say we have a B is local. B will only when main is called, then it's alive. When main finish, it will be dead, right? And for P is somewhere when it is allocated, it will be alive until it is free. So the lifetime of the global, local, and the P are different. So let's try this. So here, if my function here, I have void this local function, right? And inside here, let me have something called s, integer s, okay? And I have integer s equals 3 and I print f, right? Print f, and then I say s equals $sign d and 3, right? So here, right here, after printing this a, I actually call this local function. So s will be printed, right? But this one is fine. So s got printed. But if I try to print this s over here, if I try to print s over here.
Print 写错。
Oh, I see.
应该不会 work 啊。
Yeah, it won't work, okay, because it won't work. This one won't work, okay? This one won't work. So this one won't work, right? But my P is actually dynamic, right? But this one P actually is a global variable. So right here, if my body of P assigned with 3, right? Original my P is 7, right? So here I just copy my P, trying to let me see, copy over. So here I say my P's body, right? Right? So my body of P becomes 3. Right? So the purpose of this having this dynamic memory is that once I allocate, that one always has that as long as you provide the right reference to P, to the body. As long as I actually have a.
这样如果我那个
I actually have a dynamic memory in here.
那个 local 写 A 呢 ？A 等于3呢
Then that is a local A. That's a local A.
那不会改对不对？
Yeah. So here, if I save a local A.
No, 不是那里，不是那里，就直接 A 等于3，因为你不是已经 declare 一个 global。
Yeah, that will update the A actually.
这样会 update A。
This one will update A.
为什么它会 update A？
Because A is global, it's alive of always. This one A will become 3. Let's check, okay? It should get a 7, but
没有印了。
oh no, I did not print it. So after this, actually, let me actually print it over here. Right, A becomes 3. But if I say integer A, this is legal, okay? This one is legal. And let me put in here, let me put in A, okay? So you will see the local one, A will put in, let me see right here, this one's local A, okay? This one is, let me call it static A, okay? Static is global, okay? You see, the local A is 3, global A is 7.
对，这个懂。可是你把 integer 拿掉，把它就是用 global 的
Yeah.
印出来看看是会是什么？
So
会是3或者是7
this one?
？Yes.
This local is actually still 7. Let me see. This one actually becomes 3 because it updated over here because it's alive. A is alive for the whole program, unless that it got overridden in local. And local, that would be a different variable A in the local variable.
Okay.
So what happened is like I have some sort of stack, right? I have a main, right? I have my say local, right? And my A is defined here, right? So when the compiler trying to see, oh, right here I have an A, that's fine. If it tries to find B, but B is not there, you go to static area to see, oh, there is a B, so I use the B over there. If no, then this B is not defined. Okay. So they will check local first. When you not update your assumption, you check local first before going to stating. So remember, C has 3 types of variable. One is local, one is global, and the other one is using dynamic. Dynamics is alive when it actually been allocated. So if you try to print it before the dynamic allocation, no, that P actually is a pointer. That actually is a different pointer. It pointing to the A edges. It's not as allocated in the memory. So pointer is something like I have a pointer P, right? I have a pointer P, right? Is a pointer, I have an edges. So here I have a variable A, I have a variable B, I have a variable C, right? And they can be, one may be in global, one may be in local, one may be dynamic. And then as long as the HS got assigned to it, P will be able, body P can print out exactly which one you select. So this type of pointer actually allow it's switching the body. Dynamic memory, dynamic pointer, you can switch the body. But A, can you switch the body? No, A always the body is this one. B, always the body is this one. And C's body, actually, there's no name associated with it. You can only use the pointer to point it to it. It's dynamic. Is that okay? So that's something right here. And there's another reason why we want to use pointer. There's another reason why we want to use pointer, because of this dynamic memory allocation. Okay. So for example, if I declare here, right? And then what right here I say
print out your shit small.
Yeah, it's okay. Okay, I'm trying to print out B's 0 value, okay?
就直接 compile run.
Yeah, I know. Okay, so something like this, right?
Yeah.
And then if I try to here, I try to do this, actually void print array, okay? And right here, int, and I'm sorry, here, int, and then x, I'm sorry, x. This DV actually it will generate a lot of things by itself. Okay, right here, right? So right here, actually, I try to say for int I equals 0, I less than 3, I increase, print f. Here I say b of $D equals percentage sign D slash n. And then here I have I and B of I. Okay, I try to print out everything for that X array. So here I actually just comment out this one. So I say print array here I put B, right? Okay, I put a B there and I will print out here, right? I actually will print out this. Something wrong, let me see. Full, oh, this one need to be, this one, C right now is using the old version, right? It's actually using the old version. So this int is not allowed. Older C doesn't allow you to initialize this here. So you have two solutions. One is that you move this one to declare int I over here, and then you run like this. Okay, this OC, right? That's one solution. But usually I don't like people to do this, so that is stupid. So here I put int, and then what should we do? We go to the project option, right? And here parameter dash std equals C 11. C++ 11. Okay. Let me see. Oh, it's still not good. Let me actually, it probably is C because right now we are using C. Let me see. So let's try parameter. Not because right now it's UGCC, not HDC, not HHC double plus. So then let's do this. Wait, did I something wrong? C11. Use the option in Euclid compiler. No. Let me see my project compile option std. Oh, I'm sorry. It's C double plus compiler. I'm sorry. I should copy to here. I do not see it. Sorry. I do not check this one. Compile wrong. Okay, this one. Got it? It actually print out this also. But here, be careful, okay? Here, be careful. In your Java, when you put here, you don't assign the 3 over there. You just put your integer x, right?
Mm-hmm.
In there, right? Because this one actually is only pass the reference into there, right? But this one is different. This one actually it will pass. It will actually in C the concept is different. In C actually, if you actually assign this, right? Assign this, it actually is a whole collection of 3 data. So V is something like this. It actually assign this 1, 2, 3. Index 0, 2. So B is actually something like this. And then when you pass this, the parameter actually this another one called X. 1, 2, 3. So you will copy the value to here and then print out the value in X. I'm sorry, here actually I print B. And let me actually update it. Okay. Actually update the program. Here I should print out X instead of using B. Okay. Okay, I print out X. Okay. Right? So right here, if I do this, if in the same program I do this, over here, I put it over here, right? And then before I actually print it, I say X I increased. I'm sorry, increased, right? So I print out that one X, and let me print out. I mean, actually, wait, this guy copy and paste, and here I say B. Okay, here I print out B. So I print one X and one B, right? And actually X got updated, but my B is not updated, right? My X is updated, my B is not updated, okay? So here, let me see, this one it got updated, right? So each one of them got updated. You know why? Because this is a pointer, so it's a ages plus 3. 3, this one is a 3 ages, 3 ages, 3 ages. I'm sorry, an array of 3 elements. So if you update X, this B will be updated as well. Okay, you see that? It will be updated as well. Okay, that's because what? Because actually, you actually pass the whole 3 array into here. You pass the whole 3 array into here, and it got updated. Okay, and in fact, if you right here, you can also pass. You can also pass another one G. Okay, and then this one G, that's actually right here. Then let's copy this one over here. I say G and G over here, right? And when I pass it, I print the array. Actually, I give a B over here as well. Okay, so it passed by pointer, and then it actually also trying to get started for it. You see the G even are equal. Okay, so G is even is also equal to X, V, and G as the same. So this one actually the pointer right here.
这个 pointer G 的为什么它不是用 address B？
Yeah, that's the point I'm trying to make. So when you declare something like this,
对，
when you declare something like this, it actually is this. You have a B, and this B itself actually is a pointer. So this one is a pointer to a.
So 一个 array naturally 就是
Yeah,
一个 pointer。
yeah. And you put 1, 2, 3 over there. So B's value actually is stored with the B0's address. It actually stored with the B0's address. Is that okay? So now if
他每次刚开始都是从 B0 的那个 address， 可是他可以慢慢的在
Yeah. So let me do one more experiment, okay? Here, if I say this integer address h, right? And this one, instead of passing the B address, I put in B0's. If I put B0, it will be the value, right? And I pass in B0's address, right? And right here, let me do this. Right, so here I actually, in here, now this time I put in H. Okay, so here I put in B0's address, and then I print H. H is still the same. See? H is still the same. Do you see it? Let me run again. H is still the same. Okay, not even this, if here actually locally, if locally here I say I have, say, integer, say, body of K, right? It's a pointer, and I give you X address, right? And then starting from here, I copy. And then I passed. Here I say K, right? And here I say K increased and its body. So the first time I get in K, I will use address X address, right? And then use that to find the body, and I print null for that. And then the next one here, okay, the next one actually my K increased, and I find its body, and then K increased, finds body. Even K is the same. Can you understand this? So so basically this K, so address can be calculated. Address is used can be calculated. So here, right? This one actually I originally have a B address, right? B actually has 3 tuple, right? And then I assign this, actually X is the same pointer to here, right? And then G got assigned with what? With B's address. So B actually is over here, here. So B actually G is also assigned to here. And then the next one I use the B0's address. B0 address H is still also still here, right? And the next one I got the address, the value of X. The value of X is also the address for that array. So K actually is pointing to the same thing here. But right here I get a k's body value. So that's first one here. And then I increase k, and then you go to here, get a body, increase here, get a body. All of these get the same value. All of these get the same value. Okay, so HS actually is something that you can calculate. Something you can calculate the. So HS actually is something you can calculate to find the body. So you are not familiar with it. So if, for example, you have an A0 down to A n minus 1, right? That's usually when you declare A of n, right? Right? But if you actually assign A to K, and that actually integer point to K, right? So actually this one would be body of K, and then K increased, and then body of K increased. Something like that will be the same. You will still get all the value for that. Not even that, okay? Not even that. So here, not even that. So here, if I don't do this, let me copy again. Let me copy again, and I put it here. And instead of using K, this body, instead of doing that, let me do this, using K and put a I over here. Right? If I do this, let me see, something wrong. Let me see, video 2. K0, K1. Let me see, something wrong here. K0. Wait, it shouldn't be. Let me check. Something wrong. Let me run again. Let me see what's going on. K0 equals 2. K0 equals 2. K1 equals 0. Second K. Let me see. It's actually K. It should have the same value. Let me see. Anything wrong with that? Let me see. I, K, I. Okay, this one I'll check, okay? It should also work. I'll check for this one next time.
可以休息吗？已经有点，头已经有点。
Okay, done now. I will actually. You can stop for. Let's break for 10 minutes, okay? Is that okay?
还要再更多啊？
I have my chapter need to be finished.
Oh yeah.
Okay, let's stop for 10 minutes.
Just keep going.
Okay, so this one, that's actually, the rest of them is chapter 2 is easy, okay? But if you are tired, you can just listen, okay? But this one actually is a little bit complicated, right? But it will give you a good introduction for what's pointer. So pointer basically is a memory calculation scheme, memory address calculation scheme. Okay, it's actually a memory address calculation scheme. So now let's continue our chapter 2 actually. So last time we start with literal, and then I talk about this this one, the lowercase. I'm sorry, the long integer. So last time we talk about this different integer type, and in C language, last time I talked about there is a signed and unsigned. So there's an unsigned, there's a signed. The signed you don't need to use, don't need to write it, and then you have another one is called let me see, long, short, and normal. And they are two types, character or integer. So totally in C language, there are so many different types, right? So if you use a constant, you use a L, U, that would be signed or unsigned. you will assign the value, assign the long, L will be long, and S will be short, something like that. If you need to prepare the data, not the variable. And then you can use a scientific notation as well, okay? You can use a scientific notation as well. And it will be stored as, if you have a F, that will be stored as float. Okay, D is for double, okay? And you have, okay, D will be double. And then remember, this one is not a string. As I mentioned, a string will have a \0 at the end. So you need to add one more byte to the size of array in order to get it. This one is a string, okay? Because this one you did not specify the number of, this one is A is only a pointer. So this one, pretty much, your A this is almost equivalent to this when you declare this. These two are almost equivalent. There are some subtle difference, but it's almost the same.
是 integer 或者哦 never mind.
Character is the same. It's just a array. Is that okay? For string, you actually need to do this. Okay, and then here actually this one, if you have more, they will put A, B, C, and \0, and then the rest of them are not used. That is actually a legal string. And in fact, in C language, conceptually is string, but in fact, they are all array of characters. So no string data type. Even though we call it string, there is a string.h to be included, but in C language, it's all array of characters. Now the next one is macro. Macro, you see a defined debug. So macro is also kind of like a constant, but it's not really a constant. It's actually a preprocessor. So let's look at the program again. So here, this one I'll save. Okay, I save this one. Let me actually, I probably saved already. So let me close project. Okay, now I create a new project and C program. And then chapter 2, let me see. Chapter 2, let me create a new project. Let me create a directory called macro. And I put into macro. Okay, now we have this, right? You probably see this quite many times. This one, if not defined, not def, and then like string underline h, right? You probably see this quite often. And then you go into here, like define string. You see this many times, right? And then at the end, you end the if in the header file, right? And that is related to this macro. So macro is something like here. Here I actually say here like define this one debug 0. Okay, this is not really available. So what happens is that if debug okay. Okay, that is right. If I put a 0 over there, 0 actually means false. 0 actually means false. So actually is a normal mode, right? So if I put a 1 over here, it actually shows the debug mode, right? And actually this one is called macro. It's not constant. This one is called macro. This one's called macro. And what is macro? Macro actually is using with a preprocessor, so this will be replaced by 1. Before the compilation start, it actually has a preprocessor will process it. So here, you will check this. We saw this many times. So you have a source code, whatever. You will actually generate some preprocessor code. So that macro will be replaced by constants 1, 2, 3 into your program. So what compiler really see is 1 over here. It's a constant 1 over there. It's not actually the debug. So this one is used to debug. So right here, say here, if here I can say if debug, right? Then here I say like let me see. Okay, here integer. Let me see. Integer x equals 3. Integer x equals 5. 6. Okay, and then end if. Okay. And right here, well, let me see. Here, like print and then x equals. Okay, so I have 2 definitions for this x. So this one x equals 3. But if I change to 0, oh, I'm sorry. This is defined. So actually, if I actually comment this up, I'm sorry. Okay. No matter it's 0 or 1, it's defined. So here I need to comment it out. If I comment it out, oh, this one become not valid. Okay. So let me comment the whole thing out. Not to get out it. See right here, x it becomes 6. You know, so that one actually, when you see that if undefined, actually is like if somebody already included that H file, you basically forget about the definition of a class. If somebody did not include the .h file, you will define the class. So that's trying to avoid the duplication for definition for the class. Is that okay? That in C++ is trying to avoid the redefinition for the class. Okay, so this one is as long as you put this, it is actually defined. Even there's no value, then debug already been defined. Okay, even no value, it already been defined. You can define some value. You can define some value, and you can you will also be okay. You will not assigning any value for it. Okay, so that's actually, this is how macro work. Okay, this is how macro work. Okay, let's see this is how macro work. But macro is processed before macro, and the if define, if not define, else, and if, those are processed before what? Before you go into compilation. And the purpose of having those things is trying to customize your program. So your program can have different configuration. Say, I have a source code. I write this one for a Macintosh computer, and I also write this one for a a personal computer Windows, and I also write another one for Android. And then those same code, I want to make sure that every platform can work for it. So before that, I can actually check my define, maybe I might define something called platform. So and then I check if my platform is which platform, and then whether I need to compile this or not. Those kind of setup is using the preprocessor to handle it. Okay. Okay, the next one is my third program. So my third program demonstration of program structure. So basically, usually you have a program, you have a documentation and the preprocessor section, inclusion and macro, okay? You have an inclusion and macro over there, and then you have a global definition, external header, and the global variable and function put in there, and then main function, and then sub function behind it. But if you put a sub function behind the after the main, then you need to have the prototype either in header file. You can put those in header file. That would be easier, or you can put it in somewhere else. So let's try a simple program to figure this out. With a header file, you will see why we need a header file. And C++ header file is following C. So that's actually close this project. And then that's new project 3.
Mm-hmm.
Okay, again, I go up and then I change to project 3 is a program structure. Okay, and I send project 3 over there. Okay, over here, I have this program like this, right? And then here I can actually, again, new, right here, I can actually new another one I would call source file. So 81 source file over there. And then here I put if undefined. And then this one is what main h, right? And then define main h, right? And then here say end if, right? So here I want to have the function behind it. So I said integer square x, integer x, right? I can put x or no x or just a type. Let me try this. Integer cube. And then I just put int. The x, it just need a type. It doesn't need a variable name. But if you put a variable name, it's also okay. And then after that, I save all. So this one actually it say that I was saved, right? So I change it to header file, and I say main.h, okay? Main.h. So this file is actually called main.h. Oh, I'm sorry, that one is actually the project I create is C++. So this one actually, let me do this. Let me actually quit. I need a C project. I'm sorry. So let me new a project. C project. Okay. Same directory, but I'm going to delete that one. So here, instead of I save C, save override. Okay, override project 3. Okay. So this one's a C project. Here I have a main.c, right? It's okay now. I actually create a new header file, source file, and then here I do the same thing. If undefined main underline h, and then define main h. Here need to have a e. Okay, and then end if. Okay, one I with the parameter name, one without. Okay, and And then after that, actually I save. So here I save as again, I use a header file, and then I say name, and I replace it, okay? So now I have a main.h and main.c, right? So right here, first one, this one, and I actually declare, define, debug, and 0, okay? That's a global, the basic definition. So let's bring them this one, the program structure. That's the documentation and inclusion and macro. And the next one's the global. So the global part, I actually include, your own H file, you should do main.h, okay, right here. So that one got included into here. So if with that, you no longer need to worry about the declaration of the prototype. You can do this over there, and then I say integer square, integer, yes, integer x, and I return x times x. Sorry, from this integer cube, integer y, and then return y times y times y. So main function here, I have this printf. Okay, and then that's wrong. Hi Eric, is this okay?
Mm-hmm.
So basically, with that, you don't need to put the prototype in front of, actually it's still in front because it actually includes over there, okay?
Mm-hmm.
It actually include over there, but it's actually one module. That's one module. There's one module over here, right? And the reason why we want to have this different definition, that's because we may have multiple file. We may have multiple file, but right here, I don't want to go into that. That's too much for today, okay? So here, I have this macro structure. So variable, when we name the variable, for C language, you can use the Java style or C style, C Python style like this. Okay, you probably know this already. C style like this. This is more like the Java style, and you can keep one of them if you like Java style to keep Java style. Okay, that's the naming convention, and the length only the first 32 have the makes sense. Okay, and it's actually need to not to be a keyword and case sensitive. Okay. And declaration, these are easy. Okay, these are easy. You should declare different type. And this one, very simple program, you actually declare a variable and print it. And that I think you can just run it, but I will skip it. The next one, global and local variable. This one I explained it already. Whatever you put in between the of any function and outside of any function is called global. Okay, but you have to use it if you have to declare it before it got used. So usually don't put at the end, then you need to have a prototype. If you put a prototype, you don't assign the value, you still use a semicolon, that's fine. But that's not a good practice anyway. Okay, that's a global variable. Anything defined in a function is called local variable. So lifetime of global variable is the entire execution of the program. And that time for a local variable is just when the function is called. Okay, that's the local variable. And the next one, here are the local variable, and I mentioned it. So that's the compute area program. Let's go for the compute area program. So this one I save, close everything, and I open the CDev chapter 2. Let me see this one, chapter 2. Wait, where is compute area? Not here. Let me see, where's the compute area? This one's chapter 2, right? Let me see. Let me try it one more time. Maybe it got saved to somewhere else. Let me check. Where, chapter 2 or chapter 1? Chapter 1 had no chapter compute area. Constant 2? No. Constant 2 had no. Print name? No. Let me see if there's another one. No. Or if I save to chapter ASP. No, it's not here. Or chapter 3. Okay, anyway, that program is not that important. Okay, I'll make sure that I found this program is somewhere. I do not see this compute area. Anyway, now this one is number system. Hi, Eric, are you around?
Come on.
You can dismiss from here because I'm recording. You probably don't need this number system.
Sure.
Okay.
Bye-bye.
I know. Okay. Number system here, we have the integer type. Integers are stored in various sizes. They can be signed or unsigned. So suppose an integer is represented by a byte, that's 8 bit. Then most bit is a signed bit, and the signed bit is 0. The number is treated as positive. So we can have this, that's 75. But remember, if you put this is actually binary pattern. So the largest positive number is 127 because we use the 2's complement format. And in order to get the 2's complement, basically it's used for the this one's 1's complement, this one 2's complement, and 2's complement is actually 2's complement actually is a 2 to the power a minus x. So this one is depending on whether the data type is character is a. If the integer is actually 32, so that actually used as the negative number in our number system. And then so the way to find the 2's complement is like if my number is this, I have a 0, 1, 0, 0, 1, 0, 1, 1. I first find my 1's complement. The 1's complement is big flip. So that one is actually this one. That's a 1's complement. And then I plus 1. That is the 1, 0, 1, 1, 0, 1, 0, 1. That is 2's complement. So that actually representing minus 75 in the integer system. And the detail for this actually is very subtle. So here I actually just omit it. If you are interested, let me know. And in some of my other classes, actually I have the video for that. Okay. So here you have a character, you have show integer, long integer. Character is 8 bits. That's 0 to 255. If you are unsigned, size minus 128 to 127. Show integer 16-bit, integer is 32-bit, and then long is 32-bit. But some implementation now long is actually 64-bit. Okay, so actually you have to check your installation and version. So here it said like either integer, either the same as short or integer. That's actually old definition. You have to check the current standard. And then integer count. I'm sorry, then integer constant. So if you try to use constant 0b for binary, 0 for octal, 0s for hexadecimal, no leading things for the decimal, and then you can have actually you can have integer. You put 65, U for unsigned, L for long, UL for unsigned long, LL for long, ULL for unsigned long. And you can also have this different data type. And I say this is C99. You can include standard integer type H, a standardized integer format. You have the integer A type, unsigned integer A type. So they actually give you this different integer type. Now the reason why they use this is important because it's standardized. So you actually don't need to worry about which one it is. So you have a sign, unsigned for 8-bit, 16-bit, 32-bit, and 64-bit. And the range are over here. And two's complement for value. If you have integer x, you try to find a negative value for it. You first calculate the ones complement. That actually is a big flip. It's a big flip. So for example, you have 3. You try to find a negative 3. You have a big flip and plus 1. You will find the negative 3 will be this one, 1101. And then you add them together and drop carry, you will get 1. And so actually you get 4 minus 3 is actually 1. 1. And 2's complement is actually you big flip and then plus 1. You do equal to 2 to the power n minus 1. So that become minus x in our 2's complement system. So 1's complement is big flip. It's big flip. Original value is like this, you big flip like this, okay? This 1's complement. 2's complement, you big flip plus 1. Big flip plus 1. Okay, to find 2's complement. And 2's complement is the way we represent the negative number in C language. So addition and subtraction example. Okay, you actually minus 7, you do big flip and plus 1, you have this, and then you sum them together, you get minus 5. And this one, you have the 2 big flip, will be 0, 0, 1, 0, and plus 1. 0, 0, 1, 0, and then you big flip, you will 0, 0, 1, 1, 0, 1, and plus 1 will 1, 1, 1, 0, that's minus 2. And then you get sum together, you get 0, 0, 1, 1, and times the overflow bit, and then you get 3. This one, minus 5, minus 2, similarly. So you can solve this by yourself. Number system 2, the floating point number. The floating point number in our C system, we use the IEEE 754 standard. Floating point is single precision, that's using 32-bit. Double is using 64-bit. It's called double precision. And the single precision, you have one side bit, A exponent bit, 23 fractional bit, or mantissa. And then for the double, you have one side bit, 11 exponent bit, and then actually 52 mantissa bit. Okay, so you can have you can compile GCC-standard C99. I give you the C standard 99. You would have the STD 99 in the int. I'm sorry, STD int or STD flow for this. So actually you can do that, and you can do this dash mf pms equal this, and then something like that. Okay. So you have this. You can also include the limits that s for the maximum minimum numbers for floating point numbers. So IEEE 554, the interpretation for the floating point would be, if you have sign bit, your exponent bit and mantissa, your value will be this value. Okay, so your sign bit, if it's 0, you got 1, that's positive. If you have a 1, actually it will be -1, so that becomes negative. And then this exponent minus bias for the floating point is 127. So it's actually 1111. All ones, except the first one is 0. So actually, if you have 128, it will be 2 to the power 1. Okay. So that is it times 2. And all 0 and then 7 ones. That one is actually 2 to the power 0. And the mantissa is the fractional part. It will adjust to have a leading 0. Okay. So floating point number is actually represented by this. You have 0 dot digit, and then time base times exponents. So actually, if you have 0.2 something e to the power 2 base 10, okay, that's the floating point arithmetic. So that's actually, you have this different representation. This representation is useful if you know the scientific notation. And floating point arithmetic representation, if SK, this one actually is the set for k-bit. So in k-bit, you actually represent actually the integer value between these. And then this actually also is good if you look at the exponent. Exponent also is a set of integer. So exponent and mantissa are 2 integer section, and it is used for a floating point. Okay. So B1 minus P is called machine epsilon, the gap between one and next representing number. So underflow, overflow occur when number cannot be represented if it's too big or too small. 2 floating point numbers are added to align the decimal points. Okay, so that's a floating point number. Arithmetic operators, we have these different operators. So you have the postfix operator, and then you have unary operator. You have multiplication type, multiply, divide, and modulo. Additive, plus, minus, left shift, right shift, bit shift. Relational, greater, less than, equals, unequals. Piecewise operation, and or, and exclusive or. Logic operation. Logic operation has double S sign, double bar, or conditional statement. Assignment and augmented assignment. An augmented assignment is used to form a operation with a assignment, and then comma. So here we will have the explanation for different operator and its function. So unary operator, you have plus sign or minus sign that give you the plus sign or minus sign value for conversion of the sign. This one is easy. Arithmetic operator, plus, minus, multiply using star, slash for division. And remember that if you have two integers, that is actually a integer division. So make sure you understand that. And then precedence, you need to know about which operator will take place first, and that's the precedence. There's a way around this problem. The answer to use parentheses. Parentheses can help you to guarantee that the desired operation will be executed first. So this single slash is integer division. Make sure you understand that it's integer division if both of the operands are integers. And percentage sign for modulo. Decimal division. If you actually use double or float type, it will be decimal division. That means that you will continue to provide a floating point number. Arithmetic operator. Here you actually take modulo for the num, and then if it is actually 0, then we'll print something when it's an even number. So it's arithmetic. So let's stop today up to here, and then we still have about 50 to go on chapter 2. So today we up to this arithmetic operator because they are simple. So we will stop over here. Okay, thank you. Bye now.